Welcome back to our exercise program. So, till now we have discussed in differentiation the formulas which are obtained from first principle method, that is we derived differentiation of x to the power of n, we derived differentiation of sin x, we derived differentiation of cos x, we derived differentiation of tan x, we derived differentiation of sin inverse x from the first principle. So, based on that you can find the derivative of any functions, right. Apart from that, we derived the rules of differentiation, that is the differentiation of any constant is 0, differentiation of constant into function, there the constant is kept as it is and function is to be differentiated. Then differentiation of sum or difference of many functions, that is sum or difference rule we call it. There if we have sum or difference of many functions, there we have to differentiate each function individually by keeping the plus or minus as it is. Then we found the derivative of product of two functions, we found the derivative of quotient of the two functions. What are the formulas we derived, that I will show it on slide. You see the slide. Differentiation of x to the power of n, it is n into x to the power of n minus 1. Differentiation of 1 by x to the power of n, it can be taken as minus n divided by x to the power of n plus 1. Differentiation of root x, it is 1 by 2 root x. Differentiation of sin x is cos x, differentiation of sin x is cos x, differentiation of cos x is equal to minus sin x, differentiation of tan x is secant square x, differentiation of cot x is minus cosecant square x, differentiation of secant x is secant x into tan x, differentiation of cosecant x is minus cosecant x into cot x, differentiation of e power x is e power x, differentiation of log x is 1 by x, differentiation of constant, any constant is 0. For that I have given example. What are the constant? If you differentiate any quantity with respect to x other than x terms are treated as a 0. Differentiation of inverse functions, differentiation of sin inverse x is what? 1 by root of 1 minus, it should come minus, it is not plus, it is root of 1 minus x square. Differentiation of sin inverse x is, it is not plus, it is minus. Differentiation of cos inverse x is minus 1 by root of 1 minus x square. Differentiation of tan inverse x is 1 by 1 plus x square. Differentiation of cot inverse x is equal to minus 1 by 1 plus x square. Differentiation of secant inverse x is 1 by x into root of x square minus 1. Differentiation of cosecant inverse x is minus 1 by x into root of x square minus 1. Then rules of differentiation from 19 onwards, we call them as the formulas or rules of differentiation. If we have a function into constant k into u, what is u? U is function of x, function of x, then we have to keep constant as it is, function is to be differentiated. Next, sum or difference rule. If we have sum or difference of many functions, then we have to differentiate individually, differentiate u plus or minus differentiate v plus or minus differentiate w plus or minus differentiate other given functions. Next, product rule. The product rule it is product of two functions where u and v called as functions of x only. Differentiation of u into v is u into dv by dx plus v into du by dx. Quotient of the two functions, that is u divided by v. There we have to take v into differentiation of u minus u into differentiation of v divided by v square. It is quotient rule. In product rule, suppose if we have product of more than two functions, that is differentiation of product of three functions u, v, w, then as we done when we have a two functions, there we have to keep one function as it is and other function is to be differentiated, and it vice versa. Then here if you have three functions, then u, v, w, there we have to keep u, v as it is, w is to be differentiated, plus keep first and last function, that is u and w as it is, differentiate v, plus keep second and last function as it is, differentiate the first one. By keeping 2 as it is, 1 has to be differentiated. Like that we have to differentiate all the three terms by putting plus sign. Based on this formula, let us work out few problems. You take first problem. The given function is what? Y is equal to x to the power of 1 by 5 plus root x minus 1 by 2x plus 7x minus root of a square. This is question. Find dy by dx. Here this is treated as what? X to the power of n. X to the power of n is x to the power of n, differentiation is n into x to the power of n minus 1. What is n here? N is 1 by 5. 1 by 5 into x to the power of n minus 1 plus what is derivative of root x? Differentiation of root x is 1 by 2 root x. I have written 1 by 2 root x minus 2 is constant, we have kept as it is. Differentiation of 1 by x, this differentiation of 1 by x, that is x to the power of n, whose derivative is minus n divided by x to the power of n plus 1. Here if 2 is taken outside, what is remaining? 1 by x. What is power? Power is 1. Then derivative is minus n divided by x to the power of 1 plus 1, that is 2. Then differentiation of 7 into x, 7 is constant. According to constant into function, we have to keep constant as it is. X is to be differentiated. Differentiation of x is 1. Root of a square, root of a cube, it is constant. Differentiation of any constant is 0. Hence we get 1 by 5 x to the power of, here if you have to take LCM, what is LCM? 5 is LCM. 1 minus 5 into 1, 1 minus 5 into 1 is minus 4, that is 1 by 5 into x to the power of minus 4 by 5 plus 1 by 2 root x is taken as it is. Then here we have removed the minus sign, or we have multiplied this minus with this minus, minus into minus plus 2 into 1 2 divided by x square plus 7. This is based on which rule? It is based on the constant into function as well as sum or difference of two or more functions. Check the next problem. The next problem is what? Y is equal to 5 divided by root x minus 3 divided by x to the power of 4 plus x divided by 2 root x minus 1 by 8 root n. So, I am altering the terms here. How? The root x is there, 1 by root x. Suppose if we have root x, its derivative is known. Here it is 1 by root x is there, therefore, I am converting this into power. 5 divided by root x is taken as x to the power of half minus 3 by x to the power of 4. Here I will take x as root x into root x, root x into root x. Here root of 2x is splitted as root 2 into root x. Then I can cancel this root x into root x. Minus 1 by 8 root n, 8 is constant, n is also constant, therefore, I have taken as it is, because differentiation of any constant is 0. Then you differentiate the each term, because it is sum or difference of more than 2 terms. Therefore, first term is 5 into 5 is what? It is constant, 5 is constant, I have taken as it is. N is what? I have used this one, 1 divided by x to the power of 1 by x to the power of n is equal to 1 by x to the power of n is equal to minus n divided by x to the power of n plus 1, that is n is what? Minus 1 by 2 x to the power of half is, then it is also taken to numerator. Based on that, I have taken like that only, minus 3 into x to the power of 4, that is minus 4 divided by x to the power of 4 plus 1, plus here root 2 is as it is, root 2 is as it is, that we have to take root 2, I have to take as it is. One by root x, differentiation of root x is what? 1 by 2 root x. Along with this we have root 2. Therefore, finally, 5 into minus 1 by 2 is minus 1 by 5, x to the power of half plus 1 is 1 and half, that is 3 by 2, minus into minus plus 4 3s are 12 divided by x to the power of 4 plus 1 is 5. Here I have to write root 2 into root, because this we have to take as it is. 2 root 2 into 1 by 2 root 2 into root x is answer. You take the third one, third problem is what? 2 x to the power of 5 minus 3 into secant x plus 4 e power x plus 5 log x plus 12. Here we have 5 functions, they are connected by plus or minus, differentiate individually. We have to use sum or difference rule. 2 is taken as it is, differentiation of x to the power of 5, it is x to the power of n, differentiation of x to the power of n is n into x to the power of n minus 1, that is 5 into x to the power of 5 minus 1 is 4, minus 3, differentiation of secant x, constant is kept as it is, differentiation of secant x is secant x into tan x, plus 4 e power x, keep 4 as it is, differentiate e power x, plus 5 log x is there, keep 5 as it is, differentiation of log x, differentiation of log x is 1 divided by x, 12 is a numerical constant whose derivative is 0. Hence, we have to write 5 into 2, 10 x to the power of 4 minus 3 secant x tan x plus 4 e power x plus 5 into 1 is 5 divided by x. This is our third problem. You take fourth one, fourth problem, you look at the problem, 2 minus x square into 4 x cube plus 8 b square. The problem is of what type? Plus minus will also there, along with there are 2 brackets. When they are given in terms of bracket, you can take them as u into v. So, what the product rule says? The product rule is given as d, keep u as it is, dv by dx plus keep v as it is, differentiation of u divided by dx. According to that, first one is u, second one is v. Keep u as it is, keep u as it is, differentiate v. What is v? 4x cube plus 8b square plus keep v as it is, keep v as it is, differentiate u. This is v, this is v, this is u. Wherever we have d by dx, that is to be differentiated, other things are taken as it is. That is why 2 minus x square is taken as it is, differentiation of 4x cube, 4x cube, 4 into x cube differentiation is 3x square plus it is constant. This is what? It is a constant. Therefore, whose differentiation is 0. Then v is kept as it is here, 4x cube plus 8b square is taken as it is, differentiation of 2 minus x square. Differentiation of 2 is what? 0 minus x square differentiation is 2x. Hence, finally, we reduce it to 2 minus x square into 4 3s are 12x square plus 4x cube plus 8b square into 0 minus 2x is minus 2x. If you want, you can multiply it, otherwise you can keep it in that step only. So, when multiplying it, it becomes what? 12x square is multiplied with 2, that is 24x square, minus x square into 12x square, which is 12x to the power of 4, minus 2x is multiplied with both the terms of this bracket, minus 2x into 4x cube, that is plus into minus, minus 4 into 2, it is 8 x to the power of 4, again plus into plus plus, plus into minus minus, 2x into 8b square, that is 2 into 6, sorry 2 into 8 is 16 b square into x. So, 24 x square minus 12 x to the power of 4, because minus 12 minus 8 they are added because of the same sign, minus 12 minus 8 is minus 20 x to the power of 4 minus 16 b square x. This is product rule. Check it next one, the fifth question. It is also of product of two terms. The first product is taken as u, second product is taken as v. What the product rule says? U into d by dx of v plus v into d by dx of u. Based on that, I have written u as it is, differentiate v plus v into, this is what? This is v into differentiation of u. 2 minus 2 root x is taken as it is, a differentiation of this d by dx of x minus 2 by x. Therefore, differentiation of x is 1 minus 2 is taken as it is, 2 is taken as it is for 1 by x. For 1 by x, we have to take it as n minus n by x to the power of n plus 1. Differentiation of 1 by x to the power of n, generally we will take it as minus n divided by x to the power of n plus 1. According to that, here the power is what? 1 minus 1 divided by x to the power of 1 plus 1. Then this is taken as it is, differentiation of this 2 is constant, derivative of any constant is what? It is 0. I have taken 2 as it is. Then differentiation of root x, differentiation of root x is what? 1 divided by 2 root x. Then this bracket is simplified, 1 minus into minus, it is plus 2 by x square, x minus 2 by x into, leave this 0, minus 2 plus these 2 get cancelled, finally we have minus 1 divided by root x. If you want, you can multiply it, otherwise you can keep as it is, right. You see the sixth problem. The sixth problem is also on product rule. Here there are two brackets, first bracket is taken as u, second bracket is taken as v. What the rule says? U into d by dx of v plus v into d by dx of u. This is u, this is v, this is v, this is u. Keep u as it is. What is u? 2x plus cot x I have taken as it is. Differentiate 6x square minus cosecant x. Differentiation of 6 x square, differentiation of x square, constant into function, keep constant as it is. Differentiation of x square is 2x. Differentiation of cosecant x. So, differentiation of cosecant x is minus cosecant x into cot x. Therefore, this minus is taken as it is. For differentiation of cosecant x, we will get minus cosecant x into cot x plus keep 6x square minus cosecant x as it is. Differentiate 2x plus cot x. Differentiation of 2x is 2 into 1 plus differentiation of cot x is what? Cot x differentiation or derivative is minus cosecant square x. Then finally, we can write 6 into 2 12x minus into minus plus cosecant x into cot x plus 6x square minus cosecant x into 2 plus into 2 into 1 is 2 plus into minus minus cosecant square x. Here also you can go for multiplication or you can stop at that stage. Seventh problem is also based on product rule, that is u into v form. This is considered as u. Quickly you can scan this, u into v. X square I have taken u as it is, u into differentiation of v, v into differentiation of u. Then I have taken this is as it is, u will be taken as it is, differentiation of u to differentiation 0 minus differentiation of tan x is secant square x. Keep this is as it is, 2 minus tan x. Then differentiation of u, what is u? X square minus x into sin x. You carefully observe here, here we have x square minus x into sin x. By looking this, we will find two terms, they are separated by minus sign, but when you look it carefully, the second term is x into sin x. There we can find product of two functions, that is x into sin x. Again it will be considered as u into v. While differentiating u, you take differentiation of x square, it is, observe it carefully, differentiation of x square is 2x. Then differentiation of x sin x, it is again considered as product of two functions. There we have to differentiate them separately, that is using product rule, u into v. This is differentiated product rule. X sin x is differentiated using product rule, x into differentiation of sin x plus sin x into differentiation of x. It is having minus sign, therefore I have written the product rule in bracket. Then x square minus x sin x is taken as it is, 0 is left, minus secant square plus 2 minus tan x is taken as it is, 2x is taken as it is. Only we have to differentiate here, keep x as it is, differentiation of sin x is cos x plus keep sin x as it is, differentiation of x is 1. Finally, the old term, first two terms we have taken as it is, only the last term, there we have simplified 2x minus into plus minus x cos x minus into plus is minus sin x into 1 is sin x. This is product of two functions. You check out 8th question. So, 8th problem, it is also of product rule u into v. This is taken as u, this is taken as v, u into differentiation of v plus v into differentiation of u. I have taken v u as it is, differentiation of this, what is x to the power of 5? It is treated as x to the power of n, differentiation of x to the power of n is n into x to the power of n minus 1, that is 5 into x to the power of 4. Differentiation of x square, I have taken plus as it is, differentiation of x square is what? 2x minus of constant, differentiation of constant is 0, I have not written here, if you want you write, otherwise you leave it. Again this v is taken as it is, that is x to the power of 5 plus x square minus 7, then differentiate u, differentiation of u is x cube differentiation 3x square, differentiation of x is 1, differentiation of minus 2 is 0. See here we have product of 3 functions u, v and w. When product of 3 functions are given, we have to take product rule of 3 product of 3 functions. There we have to do what we have to do, we have to take uv as it is, differentiation of w, plus keep u w as it is, differentiate v, plus keep v w as it is, differentiate u. I have written dash for derivative, dw dash is what? dw by dx, v dash is what? dv by dx, u dash is what? du by dx. First 2 terms are taken as it is, that is x to the power of 5 e power x, differentiation of w, that is what? Differentiation of tan x. Keep first and last term x to the power of 5 tan x as it is, differentiation of e power x. Here we are differentiating v, differentiate finally u. What is u? U is x to the power of 5. Then x to the power of 5 e power x is taken as it is, differentiation of tan x. Differentiation of tan x is what? Differentiation of tan x is secant square x, plus x to the power of 5 tan x is taken as it is, differentiation of e power x is, differentiation of e power x is e power x. Keep e power x tan x as it is, differentiation of x to the power of 5, differentiation of x to the power of 5 is 5 x to the power of 4. Finally this is answer. Then you check 10th one, there we have root x sin x plus cos x minus 5x. Basically it is of what form? This is sum or difference form, u plus v plus or minus w. There how to differentiate it? We have to differentiate u, we have to differentiate v, we have to differentiate w. You see u in place of u, what is there in place of u? We have root x into sin x, root x into sin x. This is root x is to be taken as again u, sin x is taken as v. In u again we have a product rule, therefore I have used product rule. Product rule for root x into sin x is this, that is u into again u into v, uv method. Root x d by dx of sin x plus sin x into d by dx of root x plus differentiation of cos x, I have taken directly minus sin x, differentiation of 5x, 5 is constant taken as it is, differentiation of x is what? 1, then root x, differentiation of sin x is what? Cos x, plus sin x into differentiation of root x is 1 by 2 root x, plus into minus minus sin x minus 5. You see next slide, it is on quotient rule. Y is equal to 1 minus cos x divided by sin x. The whole numerator is taken as u. The whole numerator is taken as u and denominator is taken as v. This whole thing is u, denominator is v. What the quotient rule says? V into d by dx of u minus u into d by dx of v, u by v whose derivative is what? V into d by dx of u, that is u dash, minus u into d by dx of v dash divided by v square, This is d by dx. According to that, v, what is v? V is sin x. D by dx of u is what? U is 1 minus cos x, minus u is what? 1 minus cos x into sin x. The sin x is v. This is u, this is u, this is v. Whole divided by what? V square. Whole divided by is v square. Wherever we have d by dx, that term it is to be differentiated, others are kept as it is. Keep sin x as it is. Differentiation of 1 minus cos x, differentiation of 1 is 0 because it is a numerical constant. Keep minus as it is. Differentiation of cos is what? Minus sin. Minus of 1 minus cos x is taken as it is because we have to keep as it is. Then d by dx of sin x, differentiation of sin x is what? Differentiation of sin x is cos x divided by sin square x. 0, you leave the 0, minus of minus is what? Minus of minus is plus sin x, minus, here I have multiplied with cos x, minus into plus is minus 1 into cos x, 1 into cos x is cos x, plus into minus, minus into minus is plus cos x into cos x is cos square x. This sin x into sin x, sin square x minus cos x plus cos square x. This sin square x plus cos square x is taken as, this sin square x plus cos square x is taken as 1, because sin square theta plus cos square theta is always 1. Based on that, this sin square x plus cos square x is 1 minus cos x divided by sin square. So, sin square in terms of identity we can take it as using this formula, sin square theta is equal to sin square theta is equal to, we can take it as 1 minus cos square theta. That is, according to that I have written sin square theta as 1 minus cos square x. If I write 1 as 1 square, it becomes what? A square minus b square form. A square minus b square is a plus b into a minus b. There 1 minus cos x cancel. Finally, it will be remains 1 divided by 1 plus cos x. Check the next one on quotient rule. Y is equal to a minus tan x divided by a plus tan x. Again, the whole thing is taken as u numerator, whatever the numerator is there, the whole thing is taken as u, denominator is taken as v. v into d by dx of u plus minus u into d by dx of v divided by v square. So, we have to keep v as it is, differentiation of u. What is differentiation of a? A is constant whose differentiation is 0 minus differentiation of tan x is what? Secant square x, minus, keep this as it is, minus of a minus tan x is taken as it is, d by dx of a plus tan x. Differentiation of a plus tan x is a differentiation 0, differentiation of tan x is secant square x divided by a plus tan x whole square. We have to keep v square as it is. By leaving 0, you can multiply this minus secant square with all the first term, minus a into secant square x is minus a secant square x plus into minus tan x into secant square x. This is multiplied for both a as well as tan x. Here also by leaving 0, you can multiply the whole bracket a minus tan x with secant square x, minus into plus minus a into secant square x is a secant square x, minus into minus is plus tan x into secant square x. This plus tan x secant square x minus tan x secant square x get cancelled. This is minus a secant square minus a secant square, that is minus of 2a secant square x divided by a plus tan square x. This is end answer. You check the next problem, it is of little different form, because here not only to get dy by dx, we have to evaluate dy by dx at pi bar pi by 4. That means, after finding dy by dx, we have to put x is equal to pi by 4, then we have to simplify. What is y? Y is equal to 1 minus cot x divided by 1 plus cot x. So, numerator is taken as what? U, denominator is taken as what? V. We have to use which rule? Quotient rule, right? The quotient rule says that v into d by dx of u minus u into d by dx of v divided by v square. So, according to that I have written. Then wherever we have d by dx, that is differentiated and other things are taken as it is. 1 plus cot x we have to keep as it is. Differentiation of 1 minus cot x, we know derivative of any constant is 0, therefore, I have taken 0, minus is there, I have taken minus. Differentiation of cot x, derivative of cot x is minus cosecant square x. Then we have to keep u as it is, 1 minus cot x, then differentiation of v, what is v? 1 plus cot x, again differentiation of 1 is 0 plus differentiation of cot x is minus cosecant square x divided by v square, 1 plus cot x whole square. Then by leaving zeros, after finding derivatives, we leave the zeros and it is multiplied with the given term. Otherwise, here itself you can substitute the x value is equal to pi by 4. See the next step, 1 plus cot x minus of minus plus cosecant square x minus 1 minus cot x into minus cosecant square x. See, this is the next term. What we did in the next step, we multiplied with this, we have multiplied cosecant square with 1 cosecant square with cot x, 1 into cosecant square x is cosecant square x plus into plus plus cosecant square x into cot x, that is cot x into cosecant square x, minus into plus minus, minus into minus plus 1 into cosecant square is cosecant square, minus into minus, minus into minus plus, plus into minus minus cosecant square into cot, that is cot x into cosecant square x. Again we have a common terms, one is positive and other one is negative, therefore they get cancelled. finally we will have 2 cosecant square. Cosecant square plus cosecant square is 2 cosecant square x divided by 1 plus cot x whole square. This is our d by dx. If they ask only dy by dx, you can stop at this stage. Here what they have asked, we have to find out dy by dx at x is equal to pi by 4. That means what? Wherever we have x, there we have to substitute pi by 4, right. 2 cosecant square x, I have written in place of x pi by 4, 1 plus cot pi by 4, as we know that cosecant pi by 4 is 45, cosecant 45 is root 2, cosecant 45 is root 2 whole square, 1 plus cot 45, cot 45 is what? Cot 45 is 1, therefore we have written 1 whole square, 2 into root 2 square, cancel, 2 into 2 4, 1 plus 1 2 square, 2 square is 4, they get cancel, finally we will have 1. Here cosecant 45 degree is equal to root 2, root 2 cot 45, cot this learnt in the first sem only, cot 45 is equal to 1. Based on that we have taken cot 45 1, cosecant 45 is root 2. When squaring it, root square 2 cancel, here 1 plus 1 square is 4, 4 cancel, answer is 1. Check the next one. Here quadratic equations are given, whatever they may be given, their whole thing we have to take them, the whole thing we have to take them as u, and denominator completely we have to take it as v. What the quotient rule says, u into v into d by dx of u, d by dx of u minus u into d by dx of v divided by v square. So, based on that I have written, then wherever we have d by dx, that is to be differentiated and other terms are to be kept as it is, right. Therefore, first term v is written as it is, then differentiated second term 5x square, 5 for x square it is 2x, therefore, it is 10x, otherwise you can write constant into differentiation of function, plus 3x is there, 3 is taken as it is, differentiation of x is what? 1, differentiation of 8, any numerical it is treated as constant whose differentiation is 0, minus of, we have written u as it is, we have written u as it is, that is 5 x square plus 3x minus 8 as it is, then differentiation of 3 plus 4x minus 2x square, differentiation of any constant, differentiation of any constant is 0, plus, here we have a plus, therefore, we put it plus 4x, 4 into 1 minus 2 into, for x square it is 2x, then you keep this as it is, 5 into 2 10x plus 3 into 1 3, leave 0, 5x square plus 3x minus 8 is taken as it is, then finally we have 4 minus 4x divided by v square. Next one, it is quotient rule, again it is u, this is v, u by v, u into d by dx of v minus v into d by dx of u divided by v square, therefore, this is v, this is u, v into d by dx of u minus u into d by dx of v divided by v square. I have taken u as v as it is, differentiation of 1 0, differentiation of e power x is e power x, v 1 minus e power x is taken as it is, differentiation of 1 is 0, differentiation of e power x is e power x. By leaving zeros you multiply with minus e power x here, minus e power x into 1, minus e power x into 1 is minus e power x, plus into minus minus e power x into e power x, minus 1 into e power x minus e power x, minus into minus plus e power x into e power x is e power x e power x. There we get cancel these two, plus and minus e power x cancel, minus e power x is minus 2 e power x divided by 1 plus e power x whole square is answer. A little different problem this one. So, basically it is quotient rule. In quotient rule we need to apply product rule. See this question, I will show it. The whole numerator is what? It is u, denominator is v. Denominator is v, this is u. What the quotient rule says? v into d by dx of u minus u into d by dx of v divided by v square, So, 3 minus x is v, we have to taken as it is. You check differentiation of u. What is u? U is again product of two functions, one is x square plus 2, other one is sin x. So, when we have a derivative of product of two functions, definitely we have to use quotient rule. X square plus 2 into d by dx of sin x, this is according to product rule, u into d by dx of u plus sin x into differentiation of this, we have to write x square, this is not 3 minus x, we have to write x square plus 2, x square plus 2. Minus this whole thing I have taken as it is, differentiation of this, differentiation of constant is what? 0, differentiation of x, differentiation of x is what? We have to take it 1. 3 minus x, keep x square plus 2 as it is, differentiation of sin x is cos x plus sin x into differentiation of x square, differentiation of x square is what? 2x, differentiation of x square, here x square plus 2, this is to be differentiated, x square differentiation is 2x plus differentiation of 2 is constant, that is 2x plus constant. This is taken as it is, differentiation of sin x, and this is not x, this is 1. Then finally, we have taken this is this multiplication here, finally you can get the answer. It is also of the same type, numerator is u, denominator is v. What the quotient rule says? v into differentiation of u minus u into differentiation of v divided by v square. Keep secant x as it is, find differentiation of the terms. Here we have again product of two functions. What is product? 3x cube minus 4 into root x. It is again we have to take it as product rule, that means u into v. U is 3x cube minus 4 d by dx of root x plus root x into d by dx of 3x cube minus 4. It is of product rule only, u into d by dx of v plus v into d by dx of u minus 3x cube minus 4 we have to take as it is into root x, differentiation of secant x. Differentiation of secant x is what? Secant x into tan x divided by secant square x. Again in the bracket wherever we have dy dx, that is to be differentiated, 3x cube minus 4 is taken as it is. Differentiation of root x is what? Differentiation of root x is 1 by 2 root x, plus keep root x as it is, differentiate 3x cube, x cube, 3 into x cube differentiation 3x square, therefore totally it will become what? 3 into 3 9, x to the power of 3 minus 1 2. Differentiation of any constant is 0, then other terms are taken as it is. Finally, 3 x cube minus 4 divided by 2 root x we have written, and root x is multiplied for 9x square, it will become what? 9x square into root x, and other things are taken as it is. See, minus this bracket into root x into secant x into tan x divided by secant square x. This is another problem. You just see the problem. Whatever we have given, the whole numerator is taken to be u and denominator is taken to be v. Quotient rule is, it is of quotient rule. What the quotient rule says? U into d by dx of v, sorry, v into d by dx of u minus u into d by dx of v divided by v square. Then wherever you have d by dx, that is differentiated, other things are taken as it is, here this one and this. So, what is differentiation of 1 plus x square into tan inverse x? Again it is to be treated as product of two functions. The product of two functions means again we have to go for product rule. What the product rule says? U, keep first function as it is, 1 plus x square into differentiation of second function, that is tan inverse x, plus keep second function as it is into differentiation of first, what is first? 1 plus x square, minus 1 plus x square into tan inverse x, differentiation of 1 minus x square I have written as it is, then 1 minus x square it is taken to be as it is, 1 plus x square into differentiation of tan x. Differentiation of tan x is what? Tan inverse x is 1 by 1 plus x square, plus keep tan inverse x as it is, differentiation of 1 plus x square, 1 constant whose derivative is 0, differentiation of x square is 2x, minus 1 plus x square tan inverse x, take as it is, differentiation of 1 0, differentiation of 2x square is 2x. Here I can cancel this 1 plus x square, this 1 plus x square, then it will be remains what? 1 minus x square remains as it is, 0 plus 2x is what? 2x, that 2x into tan inverse x I have written, 2x into tan inverse x, plus this minus into minus, the minus into minus I have taken, plus 2x into 1 plus x square into tan inverse x whole divided by 1 minus x square whole square. So far we have discussed many problems based on constant into function, sum or difference of the functions, problems on product rule when product of two functions are given and product of three functions are given, and we have done the problems on quotient rule. So these are very important while climbing a building, like as we have to go step by step, no, one stair in we have to go one step by step. So based on that, these rules are very important. You treat them as the fundamentals. If you are strong enough in these fundamentals, definitely you can do the other types of differentiation, that is we have a different functions. How to differentiate all those functions, let me discuss in the next class. Thank you very much.